Question 17. It's an angle problem. It's actually using bearings, but the bearings don't really mean anything in this because they've been taken out of the new syllabus. You only actually have to have an idea of what they look like. So, there's a Coast Guard station at point A and at point B. B is due east of A. The distance from A to B is 12 kilometres. There's a rowing boat at point R. R is a bearing of 160 from point A and a bearing of 220 from point B. There's a speedboat at point T. T is 5 kilometres south of point A. So all of that's on the diagram. Yeah, they're only really reiterating here, but it's worth you going through just to check that they haven't missed anything off deliberately. Work out the shortest distance from T to R. Okay, so what we're trying to find out is this distance here. Yeah, that's what we're trying to work out. Giving your answer to one decimal place, that means we're going to be using a calculator. You must show all your working. Okay. First things that are obvious to me, we've got a triangle here, we've got a triangle here. I can easily work out the angles in this triangle, so I'm going to do that first. Yeah, even without thinking about what the question is telling me, I'm seeing an angle problem, and what I do is I start to work out which angles I know. Okay? I know that that is 90. And if that is 90, then this one must be 70. That's 220. I know that up to there is going to be 270. So this bit must be 50. Okay, that's 70, that's 50. Which means that this third angle here must be, well, 70 add 50 is 120, so that must be 60 degrees. Okay? So we've got these three angles now, and what we're trying to find out is this length here. Well, we've got another thing we can add in, which is if that's 70, then that must be 20. Okay? So we've got the makings of an angle rule here. We've only got one angle. So we don't know that angle, and we don't know that angle. So that means that we're going to end up having to use the cosine rule, because the cosine rule only requires one angle to use. And to do that, we need two sides. So we know that side, and we're trying to find that one, so this one must be workoutable. Okay? So if I take a look at it, well, I've got three angles, and I've got one side there. So I can work out this side here using the sine rule. Okay? So if I call that x, and I'll call this one y. Okay? So sine rule is, you put the unknown on the top, so I'm trying to find out the side, so it's going to be a over sine a equals b over sine b. So in this case, we'll have 12 over the angle opposite, so sine 60 equals x over sine angle opposite, which is 50. Okay, and then I'm going to work that out. So I do that by doing, well, I'm going to need to multiply by sine 50 to get x on its own. So x equals 12 over sine 60 times by sine 50. Okay, if I work that out with my calculator, and I get 10.329. So that's our value of x here. Now, we can use the cosine rule to work out y. And if you remember, and you can always check the front of your paper, the cosine rule looks a lot like Pythagoras. A squared equals b squared plus c squared minus 2bc cos a. So we're trying to find out the length of this side here, which is conveniently opposite of 20. So y squared equals, and then we need our two sides. It doesn't matter which way around they are. So 5 squared plus 10.329 squared minus 2 times 5 times 10.329 cos, and our angle is 20. So if I work that out, one calculator thing. The nice thing about the cosine rule is that if you're trying to find out the length of a side, it's just type all that into the calculator, which is convenient. So you've got 5 squared plus 10.329 squared. Notice that I've kept that as long as possible. Minus 2 times 5 times 10.329 times cos 20. And that comes to 89.537. But of course that's not the length of that, and you probably think to yourself, that can't be 89, that's 5 and that's 10. So we have to do our square root. Square root of 89 is 9.46. And of course it asks to one decimal place, so that will equal 9.5 kilometres.